Hello dear students, welcome to EE211 Laboratory 1. This lab is on the single phase transformer. Since this is the first lab for your course, we will first go over the lab world machines learning setup. Okay. The first module is the power supply module. Okay. This module can provide both AC and DC voltage. The first set of terminals is the 240 volt or 415 volt fixed output. Now why it says 240/415? Because each phase with respect to neutral you will have 240 volts, and between phases you will have 415 volts. The second set is the variable 0 to 240 volt or 0 to 415 volt. Then you have DC 0 to 240 volt variable and the fixed DC 240 volts. Okay. These are the circuit breakers for the individual points. Okay. This is the main switch. Okay. The on position is at 1, and this knob is used to change the voltage. It goes from 0 to 100%. 100% being 240 volts or 415 volts respectively. The transformer, this is the single phase transformer. Okay. This is the lab volt series 8341-2A. We will post a picture of this on Moodle so that you can have a closer look. The outside and as well as the inside. Now let's move on to the procedure. Okay. You can do the first part yourselves. Let's go to the second part. Okay. It says the list the rated voltage for each of the 3 windings. Okay. For terminal 1 to 2 it's 240 volts. Terminals 3 to 4. Okay. 5 to 6. These you can get from the picture that we post, okay, because it's written on the transformer itself. Likewise for part B, the rated voltage, you can get that as well yourselves, and part C as well. Okay. Now it says using the lowest range of your analog multimeter, measure and record the DC resistance of each winding. Okay. Now let us do that. First one is terminal 1 to 2. Now as I go along, you have to record the values yourselves. Okay. Next one it's terminal 3 to 4. Then terminal 3 to 7. Then terminal 7 to 8. Then terminal 8 to 4. Then terminal 5 to 6. Then terminal 5 to 9. The last one is terminal 9 to 6. Okay, let's move on to part 7. Says connect the circuit shown in figure 1-2 Notice that current meter I2 shorts the winding 5 to 6. Okay, so we have just connected a ammeter to the secondary winding 5 to 6. Okay, so the first meter is in volts. Okay, and this is your E1. Then you have I1, this is in milliamps, and you have I2, which is in amps. Okay, we have to adjust the voltage so that we get a current of 0.2 I2. Okay, so we have 0.2 here. Please record. Okay, we return the voltage to 0. To part 8. Okay, now the same thing we will do, but the current meter will be connected to winding 3 to 4. Okay, now this meter will read I3. This is your E1, I1. Please note the values. Okay, now let's move on to part 9. Says you will now determine the effect of co-saturation on the exciting current of a transformer. Okay, so we have connected a voltmeter across the output terminals 5 and 6. Okay, so this is going to be our E2, this will be E1, and this will be I1. Okay, this meter will read in milliamps. Okay, now referring to the table 1-1, let's adjust the voltage to 50 volts. Okay, please record as I go along. Next, 100 volts. Next, 150 volts. Next, 200 volts. Next, 250. Next, 300 volts. Lastly, 350 volts. Let's go even further to 400 volts. Okay. Now let's go to part 10. Says you have to plot your required voltages on the graph on figure 1-5. Okay. So when you plot E1 versus I1, you should get a saturation curve for the transformer that we have been dealing with. After that, you have to attempt your test your knowledge questions and compile the report. Thank you.